All right, so we are going to talk about enzyme kinetics, and in particular, we're going to be focusing on binding order. In the next video, you'll find some information, or you'll find discussion of inhibition and inhibition patterns, but for this one, we're going to be focusing on binding order. Okay, so what is the difference between a kinetic versus a chemical mechanism? A kinetic mechanism is the order of substrate addition and product release in an enzyme catalyzed reaction. Whereas a chemical mechanism is the chemical pathway of conversion of your substrate to the products, including the structures of any sort of intermediates. We've already kind of discussed that in terms of we've discussed a transition state, and so that would be considered, that S double dagger. That is a different molecule than the substrate. That's a different molecule or chemical molecule than the product. And so in order to actually understand an enzyme, you have to understand both of these different things. Okay, so you have to understand what these different molecules look like and through the progression of the reaction. You also have to understand the sequence. So the sequencing of, so that both the kinetics and the chemical mechanisms, you have to understand both of those. Okay, so kinetic mechanism can disprove a chemical mechanism. Now, a bi-substrate reaction. A bi-substrate reaction is something that's really a little bit more common than you would expect it to not be, if that makes any sense. So we talked about Michaelis-Menten models of enzyme kinetics, and we were always talking about it regarding a single substrate. So we had this simple model of E plus S yields E plus P. And of course, there's more to it than that, but we were focusing on a single substrate. But more times than not, you're going to have an enzyme that has multiple substrates. And so generally, what you're talking about, and the majority of enzymatic reactions have, well, two substrates. And so in this display down here, we've got A and B as our two different substrates, and our E is our enzyme that is going to produce two different products. So we've got two different substrates underlined in red with a star-ish structure there, and then we've got our two different products that are going to be produced by our enzyme. Okay, so a bi-substrate or bi-substrate reactions account for 60% of known enzymatic reactions. Now, what does that actually kind of look like? So, as an example, what we have here is two different examples of bi-substrate reactions. The first one is for the protease trypsin. That is an enzyme that cleaves polypeptide bonds. And so that would take in a molecule that is a polypeptide, and it's going to break it into, well, product and product. It's going to use its polypeptide or use a polypeptide and water. And so when you think about two substrates, well, one of those substrates might be something like water. Alternatively, this enzyme right here, alcohol dehydrogenase. This is an enzyme that catalyzes an oxidation reduction reaction. And what this is going to do is it's going to take something like ethanol. It's going to take ethanol and it's going to use a second substrate, NAD+, which is common for oxidation reduction reactions, and it's going to make some acetaldehyde and NADH. Okay, so we have two different reactions, so two examples of reactions, and so you can always classify it, or you can look at it as substrate 1 and 2. 2 and 1. And in some cases, you're going to get two unique products, and in other cases, well, you might have a product where it's kind of combining things. So if you think back to Gen Chem 1, it might be like a combination reaction or a synthesis reaction. Okay, so